Welcome to this walkthrough guide on how to use the hash operator in Excel. Are you tired of constantly adjusting your formulas every time your data changes? Sick of manually dragging that fill handle down hundreds or thousands of rows only to have it break when you add new data? Or perhaps you've built complex offset or index match formulas just to make your ranges dynamic, and they've become a nightmare to manage. Well, those days are over. Modern Excel has introduced dynamic array formulas, and a tiny but incredibly powerful symbol is the key to unlocking their full potential. And that is the hash operator. So let's dive straight in. Right, let's get hands-on and see the hash operator in its most fundamental role, simply referring to the result of another dynamic array formula. This is the building block for everything else we'll do. Imagine you've generated a list using a function like unique or filter, and you just want to display that exact same list somewhere else on your sheet, maybe for a report summary, knowing that it might grow or shrink later based on your source data. First, look here in column A on my screen. I've got a simple list of Australian cities, and you can probably spot that there are some duplicates in there. Sydney appears more than once, and so does Melbourne. Our first task is to get a clean, unique list from this source data. So I'm going to click into an empty cell, let's use cell C2 over here, and I'll start typing our first dynamic array formula, equals unique and an open parentheses. Now the unique function needs to know where the original list is, so I'll use my mouse and select the range containing the cities, which is A2 to A10 in this case. I'll close the parentheses and press enter. Instantly, notice two things happening on my screen. First, Excel hasn't just put Sydney in cell C2 where I typed the formula. It has automatically filled, or spilled, the other unique city names, Melbourne, Brisbane, Adelaide, into the cells directly below it, C3, C4, and C5. These modern Excel functions that automatically fill multiple cells are called dynamic array formulas, and they are incredibly powerful. Second, can you see this subtle blue line that's appeared around the cells? That's called the spill range. It's Excel's way of visually showing you that the entire area has automatically filled with the results. A key thing to remember is that this spill range can automatically grow or shrink if our source data in column A changes. Now, here's where our star player, the hash operator, comes in. Suppose I want this exact same unique list to appear over here, starting in cell E2. I could just type equals C2 into cell E2, but if I did that, it would only return Sydney from cell C2. If I then manually copied that formula down, I'd have to guess how many rows I need, and crucially, if my unique list in C changed their size later, my copies in E wouldn't automatically update. That's the old manual way. Instead, watch this much smarter approach. I'll type the equals sign in cell E2 to start a formula, and then I simply use my mouse and click on the very first cell in my unique result over in column C, that being cell C2. Now pay close attention to the formula bar as I make one little change. What I've done here is I've added the hash symbol right after it, so the formula now reads equals C2 hash. That hash is the magic instruction. It tells Excel, don't just refer to the single cell C2, I want you to refer to the entire dynamic spill range that starts at cell C2, whatever its current size is. Now I'll press enter, and look at that. The entire unique list from C2 is perfectly mirrored, starting in cell E2. It's automatically filled in exactly the right number of cells. But here's the truly brilliant part, demonstrating its dynamic nature. Let's go back to our original source column over here in column A. I'm going to add in a new city that wasn't there before. So let's type Darwin down here in A11. Now keep your eyes on both column C, our unique result, and column E, our hash reference, as I press enter. Did you see that happen? Almost instantly, the unique list in column C automatically expanded to include Darwin down at the bottom. And the blue spill range border has adjusted too. And crucially, looking over at column E, our formula has also automatically expanded. Darwin has now appeared without us having to touch or modify that formula in E2 at all. This is the core power of the hash operator. It creates a live dynamic link to the entire result of a dynamic array formula, ensuring that any subsequent formulas, charts, or lists that are based on it are always reflecting the most current data. Think about using this for showing filtered results on a summary dashboard. They'll always be up to date without any manual fuss. Okay, so we've seen how the hash lets us reference an entire dynamic spill range, and that's great for displaying lists. But what about performing calculations on those dynamic results? For instance, maybe you need to count how many unique items were found, or sum up a list of filtered sales figures. Before dynamic arrays and the hash operator, you'd often have to use complex formulas or manually adjust your sum or count ranges. But not anymore. Let's stick with our unique cities list that starts in cell C2, created by our unique function. Now suppose we want a live count of exactly how many unique cities are in this list at any given time. I'll click into another empty cell. Let's go with G2. To count items, we often use the COUNTA function, which counts all non-empty cells in a range. So I'll type equals COUNTA and an open parentheses. Now normally you'd select a fixed range with all of our data, but we know that this range might change. So instead, just like before, I'll simply click into the first cell of the spill range, which is C2. And again, watch the formula bar, I'm going to add in that hash operator. This tells COUNTA, count everything currently in the spill range starting at C2. I'll close the parentheses and press enter. And here's our result. It correctly counts all of the unique cities. Now, let's test that dynamic part again. I'll go back to the original data in column A and we'll add another unique city. Let's add Hobart to A12. Keep your eye on the unique list in C and importantly on our COUNTA result in G2. I press enter, the unique list instantly adds Hobart, the spill range expands, and look at G2. Our COUNTA formula immediately updated its result as well. We didn't have to edit the COUNTA formula at all. The C2 hash reference automatically adapted to the new, larger spill range. Imagine how useful this is. If this were a list of sales figures returned by a filter function, you could use sum C2 hash to get the total sum, or average C2 hash to get the average. And these calculations would always be correct, even if the number of filtered results changed from 5 to 500. It makes creating dynamic summary statistics incredibly straightforward. Right, this next one is a real crowd pleaser and solves a very common Excel frustration: creating drop-down lists for data entry that automatically stay up to date. Think about lists of employee names, product codes, or project statuses. These lists often change, and manually updating the source range in the data validation settings every single time is tedious and easy to forget, which can lead to errors. The hash operator provides us with a brilliant solution. First, let's make our source list even better. I'll modify our formula in C2 slightly. Instead of just unique, let's wrap it in sort so that the list is always alphabetical, which is nicer for a dropdown. So I'll change C2 to equals sort unique A2 to A12. Press enter, and now our unique list spilling from C2 is nicely sorted alphabetically from Adelaide to Sydney. Now let's say we want to create a drop-down list in cell H2, allowing users to select one of these cities. I'll click on cell H2 to select it, and then I need to go to the Data tab up here on the Excel ribbon. Within the Data Tools group, I'll click on the Data Validation button. This opens the Data Validation dialog box. Here, under the Settings tab, the first thing we need to do is change the Allow criteria from any value to a list. This tells Excel that we want a drop-down list. Now, the crucial part is the source box. This is where you tell Excel where the list items come from. We're going to type our dynamic reference. And it's always best practice to lock the starting cell. just in case you wanted to copy this data validation rule to other cells. So I'll type equals, followed by a $sign, and our column C, another $sign, and our row 2. And then finally, we add in our hash operator. So the full source reference is equals $C $2 hash. This $sign notation makes it an absolute cell reference, ensuring it always points to cell C2 as the start of our spill range. That's it. Make sure the in-cell dropdown is ticked, which it usually is by default, and click Apply. Now take a look at cell H2. It has a little drop-down arrow next to it. When I click it, voila! There's our list of sorted cities: Adelaide, Brisbane, Darwin, Hobart, Melbourne, Sydney. Perfect! But here's the test. Does it update automatically? Let's now go back to our original data in column A and add in yet another new city. Let's put Perth in A13. Now, I don't need to touch data validation again. I just go back to cell H2, click the drop-down arrow, and look, Perth has automatically appeared in the list, neatly slotted in alphabetical order because our source formula in C2 used that sort function. This is fantastic for any scenario where you need users to select from a list that might change. No more broken or out-of-date dropdowns. It just works, dynamically linking the validation source directly to your spill range. Now, visualizing data is key, but charts based on data that changes size can be a real headache. If you filter down from 100 rows to 10, or sort it so that you only show the top 5, you'd normally have to go into the chart's data source settings and manually adjust the ranges every single time. With the hash operator, we can make the charts update their own source data dynamically. Let's set up a slightly different example. Here in columns B and C, I have some sample data, month and sales figures. Now maybe I only want to chart the months where sales exceeded, say, $5,000. I can use the filter function for this. Over here in cell E2, I'll type equals filter and an open parentheses. The array I want to filter is my whole data range, B2 to C10. The condition, or the include argument, is that the sales column, C2 to C10, should be greater than 5,000. I close the parentheses and I press enter. Okay, so filter has spilled the months and the corresponding sales figures that meet our criteria, starting in cell E2. You can see that the spill range now includes both columns. So now let's insert a chart based on this filtered data. I'll select the entire spill range that just appeared, from cell E2 down to F whatever. Even if I had just selected cell E2, Excel is smart enough to figure it out, but selecting the whole range is still a good habit. Now with this dynamic range selected, I'll go to the Insert tab and choose a simple clustered column chart. Excel creates the chart. Now traditionally, you might think that this chart is based on that fixed range, but modern Excel is much smarter than that. Because we created the chart from a dynamic array spill range, Excel has automatically linked the chart source to that dynamic range using the hash operator behind the scenes. We don't even need to edit the data source ourselves. So let's prove it. We'll go back to the filter formula in cell E2. I'm going to change the criteria, and instead of sales greater than 5,000, let's change it to greater than 7,000. I press enter. The filtered data in columns E and F shrinks because fewer months now meet that criteria. And look at the chart. It instantly redrew itself to show only the remaining months and their sales. If I had changed the filter to greater than 2,000, the filtered list would grow and the chart would automatically expand to include all of the new bars. This is essential for creating dashboards or any report where you want your charts to always reflect the current state of your dynamically filtered or sorted data without any manual chart editing. It's honestly so much simpler. Alright, we've seen the hash operator used for basic references, calculations, data validation, and charts. Now let's see how you can chain some of these ideas together using the hash operator to link the output of one dynamic function as the input for another. This is where you can build really powerful multi-step analyses that remain fully dynamic from start to finish. For this example, I've got a slightly more detailed table here. Excel has called this one Table 3, with columns for sales rep, region, product, and sales amount. The first step, let's filter this table to show only the sales records from the North region. I'll click into cell G2 and type equals filter table 3 region equals North. Using table structured references makes it easier to read. I now press enter and Excel spills all the rows and columns from table 3 that match the North region. You'll notice that the spill range starting at G2 now covers multiple columns and rows. Now suppose for my report I need to see these North region sales, but I want them sorted by sales amount, which is the fourth column in our spilled result, from the highest sale down to the lowest. I can use the sort function for this. So in another cell, say L2, I'll type equals sort and an open parentheses. Now, what array do I want to sort? I want to sort the results of my filter operation. So I select the filter's spill range, which is G2 to J6. Excel automatically changes it to G2 hash. This G2 hash now represents the entire multi-column, multi-row output of the filter function. Next, I need to tell sort which column to sort by. Sales amount is the fourth column in the G2 hash range. So I type, comma, 4. And I want them in descending order, highest first. So I'll type, comma, -1. Close the parentheses and press enter. And would you look at that? Starting in cell L2, we now have the North region sales records dynamically pulled by the filter and now also dynamically sorted by sales amount, highest to lowest, spilling across multiple rows and columns. And we can even take this one step further. Let's just say I want a quick count of how many sales transactions occurred in the North region after sorting. I could use count A on one of the columns of the sorted result. For instance, in cell Q2, I could count the rep names in the first column of the sorted range, like this. Here, index L2 hash 01 is a way to dynamically refer to just the first column of the entire spill range starting at L2, and count A counts the entries there. Now for the final test of this chain. What happens if we change our initial filter? Let's go back to the filter column in cell G2 and change the region from North to South. Watch the screen closely as I press enter. The filter results starting in G2 instantly update to show the South region sales. Because our sort formula in L2 references this spill array, it automatically resorts the new South data. And because our count A formula references the sort result via L2 hash within the index, it also updates to show the count of South region transactions. The entire chain updated automatically just from changing one criterion in the first function. This is the elegance of using the hash operator to connect dynamic array functions. You can build responsive, interconnected calculations that adapt seamlessly as your data or criteria change. So there you have it. The hash operator is your key to unlocking the power of dynamic arrays in Excel. Using the hash operator fundamentally changes how you can build spreadsheets, moving away from manual adjustments towards truly dynamic and responsive models. It saves time, reduces errors, and makes your work substantially more efficient. Try using the hash operator with different dynamic array functions and see what you can build. The best way to learn is by doing. Now just remember, you will need a version of Excel that supports dynamic arrays, which primarily means Microsoft 365 subscribers or users of Excel 2021 or newer. Happy spreadsheeting, and I'll catch you in my next video. Thanks for watching. If you'd like to see more content like this, be sure to check out the channel. And if you like what you see, don't forget to hit that subscribe button.